Hello everyone, welcome to the digital classes. In the last session, we have studied about the divisibility rules. See the learning objectives of today's classes. The student will be able to differentiate between the terms, factors and multiples, composite numbers and prime numbers, LCM and HCF. List the multiples and factors of composite numbers. He will also be able to find the HCF and LCM using factor tree, prime factorization method and long division method. Here we will take 6 coins and arrange them in different ways. So, here we have taken 6 coins arranged in 6 columns and here we have 1 coin in each column. So, number of columns are 6, total number of coins is equal to 1 multiplied by 6, that is equal to 6. The next arrangement, we have 3 columns. Here as we see 1, 2 and 3 columns and we have 2 coins in each column. Number of columns are 3 and total number of coins is equal to 2 multiplied by 3, that is equal to 6. Next we have 1 and 2, first column and second column, 3 coins in each column. Number of columns is equal to 2, total number of coins is equal to 3 multiplied by 2, that is equal to 6. Next, one more way of writing is, here we can see 6 coins in each column. So, total number of coins is 6 into 1, that is 6. So, 6 can be written as product of two numbers in different ways. How will you write? 6 is equal to 1 into 6, 6 is equal to 2 into 3, 6 is equal to 3 into 2, 6 is equal to 6 into 1. So, finally, we can say that the factors of 6 are 1, 2, 3 and 6. Now, let us take the factors of 6, that is 1, 2, 3 and 6 and note down some important points based on these factors. Here you can see in 1, 2, 3 and 6, 1 is a factor of every number and is the smallest of all the factors. And next one, every number is a factor of itself and is the greatest of its factors. Every factor is less than or equal to the given number. So, let us consider table where here you can see the number divided into factors and the number of factors of that particular number. So, let us start with 1, the factor is 1 and number of factors are 1. Next, the number is 2, factors are 1 comma 2 and you have number of factors 2. Next number is 3, the factors of the number 3 are 1 and 3 and number of factors are 2. Next 4, what are the factors of 4? 1, 2 and 4 and number of factors of the number are 3. Next number is 5, factors of 5 are 1 and 5 and the number of factors are 2. Next, the number is 6, the factors are 1, 2, 3, 6 and the number of factors are 4. The next number is 7, whose factors are 1 and 7, number of factors are 2. In the last call here, if you observe the number of factors, 1 has only one factor, 2 has 2 factors, 3, 5 and 7 have 2 factors each, whereas 4 and 6 have more than 2 factors. So, what can we conclude from this? The numbers having only 2 factors, 1 and the number itself are called prime numbers. So, in this table as you can see 2, 3, 5, 7 have factors 1 and the number itself as their factors. So, 2, 3, 5, 7 are called prime numbers. Next, 4 and 6 have more than 2 factors other than 1 and itself. And those factors as you can see here, 4 has factors 1, 2, 4, that is 2 is extra factor here other than 1 and 4 and in factors of 6, 2 and 3 are the extra factors other than 1 and 6. So, you can conclude that 4 and 6 which are having more than 2 factors are called composite numbers. And here one more thing, as you can see 1 is having only one factor, that is 1 itself. So, you can say that 1 is neither prime nor composite. the numbers whose only factors are 1 and the number itself are called prime numbers. Try these. What is the smallest prime number? As we have already seen in the table, it is 2. What is the smallest composite number? It is 4. What is the smallest odd composite number? It is 9. Children, now let us see here a table showing the numbers from 1 to 100. 1 is neither prime nor composite number, so we will strike off 1. Next, 2 is a prime number as we all know, so I encircle 2 and strike off all the other multiples of 2, that is 4, 6, next one is 8 and so on up to 100 as you can see here. All the multiples of 2 have been struck off here. Next, the next prime number as we all learned just now is 3. So, the next multiple of 3 is 6. So, we will cross 6. The next multiple of 3 is 9. So, let us cross 9. Next 12, 15 and so on up to 99. Next prime number is 5. So, let us strike off every multiple of 5 starting from here. Next multiple is 10, next one is 15, 20 and so on up to 100. Next prime number as we already learnt, it is 7. So, we will strike off all the multiples of 7. 7 2s are 14, 7 3s are 21 and so on. So, the remaining numbers as you see here 11, 13, 17, 19, 23, 29, all these numbers which are encircled here up to 97 are called prime numbers. So, children, total how many prime numbers are there below 100? As we can see here, you can count them. We have 25 prime numbers below 100 and the numbers that are strike off, they are called composite numbers. As we have already learnt, one here is neither prime nor composite number. Observe the numbers 3 and 8. What are the factors of 3? Yes, the factors of 3 are 1 and 3. Now, what are the factors of 8, children? Yes, the factors of 8 are 1, 2, 4 and 8. Now, the common factors for both 3 and 8. As you can see here in these two, 1 and 3, 1, 2, 4 and 8. So, the common factor for both 3 and 8 is only 1. So, what can you conclude from this, children? So, we can say that the numbers which have only 1 as the common factor are called co-primes or relatively prime numbers. Let us consider few examples. I have taken pair of prime numbers. As you can see here, 3, 5 is one pair of prime numbers, 5, 7 is another pair, 11, 13 is another pair of prime numbers, 41, 43 is one more pair of prime numbers. By seeing these prime numbers, what you can say? 5 minus 3 is 2. Next, 7 minus 5 is also 2. 13 minus 11 is also 2. 43 minus 41 is 2. So, what do you observe here? The difference between the two prime numbers here, what we have taken is 2 in all these pairs of prime numbers. What do you observe from these pairs of prime numbers? We observe that they differ from each other by 2. So, the above pairs of prime numbers are called twin primes. Let us see the prime factorization. Let us consider an example 24. As you can see here, 24 can be written as 1 into 24 gives us 24, 2 into 12, 3 into 8, next one 4 into 6 and the last one if you see here 2 into 2 into 2 into 3. So, 24 can also be written in this way. So, what is prime factorization? Prime factors of 24 as you see here you can write them as 2 into 2 into 2 into 3. Now, what do you mean by prime factorization? If you can write a number as the product of factors which are all prime numbers, then it is known as prime factorization. Thus, in prime factorization, one more thing to be noted, that is the factors obtained cannot be further factorized. There are different methods to find the prime factors of a given number. So, let us see what are they. First one, factor tree method. 60, as we all know, can be written as the product of two numbers. As you can see here, it is 4 into 15 gives you 60. Further factorize 4. Yes, 4 can be factorized as the product of two more numbers, and 15 can also be factorized as the product of two more numbers. So, what are they? So, 4 can be written as 2 into 2 and 15 can be written as 3 into 5, prime factors of 60. As you can see here, we can say that 60 can be written as 2 into 2 into 3 into 5. 2, 3 and 5 all are prime numbers. Now, let us find the prime factorization of 60 by using division method. Here you can see 60 is divisible by 2. So, the first prime factor 2. So, let us divide 60 by 2. So, 2 30s are 60. Next, if you divide 30 by 2, we will get 15. Children, as we know that 15 is divisible by 3, 3 5s are 15, and finally 5 is divisible by 5. So, if you divide 5 by 5, we will get 1. So, you can further write 60 as the product of prime factors in this manner. As you can see here, 60 can be written as, so 60 is equal to 2 into 2 into 3 into 5. Now, common factors, as till now we have studied about factors, multiples and prime factorization. Now, let us see what are the common factors and what can you learn from this. So, here in this table you can see a number 12. What are the factors of 12? 1, 2, 3, 4, 6 and 12. What are the factors for 18? 1, 2, 3, 6, 9 and 18. Now, in these two sets of factors here, what are the common factors you observe? Let us see here. The common factors of 12 and 18 are 1, 2, 3 and 6. So, in all these common factors here, what is the highest common factor? The highest common factor is 6. So, we can say that the highest common factor or HCF of 12 and 18 is 6. Method of finding HCF. So, to find the HCF of prime factorization, let us take an example here 12, 30 and 36. First, we will factorize 12. 2 6 are 12. Next, 6 is divisible by 2. 2 3s are 6. Next, 3 1s are 3. Similarly, 30. 2 15s are 30. 3 5s are 15 and 5 1s are 5. Next, 36 is divisible by 3. So, 3 12s are 36. Again, 12 is divisible by 3. 3 4s are 12. 4 is divisible by 2. 2 2s are 4. 2 is divisible by 2. So, it is 2 1s are 2. Now, as we have done the factorization, we will write them as the product of prime factors. Here, you can see 12 can be written as 2 into 3 into 2. Next one, 30. 30 can be written as 2 into 3 into 5. Next, 36 can be written as 2 into 3 into 2 into 3. Now, in these three, what are the common factors? Let us see. Now, here in these you can see 2 is a common factor for all the 3 numbers. Similarly, 3 is also a common factor for all the 3 numbers. So, we can say that the common factors of 12, 30 and 36 are 2 and 3. So, you can write their product as 2 into 3 is equal to 6. We can say that the HCF of 12, 30 and 36 is 6. HCF by continued division method. So, let us find the HCF of 56 and 64. Now, as you see here, 56 is the divisor and 64 is the dividend. So, 56 ones are 56, and if you subtract 56 from 64, the remainder is 8, and here you can see 8 is the remainder and 56 here the first divisor becomes the dividend in this case. So, divide 56 by 8, 8 sevens are 56. So, subtract, you are going to get the remainder as 0. So, what can you say? Here the last divisor here is 8. The last divisor is 8 when remainder becomes 0. Thus, we can say that the HCF of 56 and 64 is 8. Now, let us find the HCF of 3 numbers 40, 56 and 60. For this, first let us find the HCF of any 2 numbers. Now, I am taking here the small numbers 40 and 56. If you divide 56 by 40, 40 ones are 40 and the remainder is 16. So, here you can see 16 becomes the divisor, the first divisor becomes the new dividend. So, divide 40 by 16. As we all know, 16 twos are 32, and what is the remainder? The remainder is 8. Now, here 16 is the second divisor which becomes the dividend in this term, and 8 is the divisor. So, 8 divides 16 twice. So, 8 twos are 16, and the remainder, see here the last divisor as you can see here is 8. So, what can we say? We can say that the HCF of 40 and 56 is 8. Now, find the HCF of third number and the HCF of the first 2 numbers, that is, let us find the HCF of 60 and 8. Now, 8 divides 60, 7 times 8 sevens are 56. So, remainder is 4 and 8 becomes the new dividend in this case. So, 8 divided by 4, 4 twos are 8 and the remainder becomes 0. As you can see here, the last divisor here is 4. So, what can you conclude from this? We can say that the HCF of 8 and 60 is 4. Further, this number is the HCF of the given 3 numbers, that is the HCF of 40, 56 and 60 is 4. Now, we will go for the next topic, that is multiples. All the numbers that are exactly divisible by a given number are called multiples. For example, multiples of 2 are 2, 4, 6, 8, 10 and so on. Multiples of 3, 3, 6, 9, 12, 15 and so on. Similarly, multiples of 8, 8, 8 twos are 16, 24, 8 fours are 32, 8 fives are 40 and so on. So, next one, now we learn how to find the least common multiple by doing a small activity here. How to find the least common multiple, that is LCM, by performing a small activity. Now, I have considered a number line, and as you can see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, you can observe here, first I will consider all the multiples of 2. 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10 and 2 sixes are 12. Now, next one, the multiples of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. Now, by observing this activity, what are the common multiples in this case? As you can see here, the common multiples are 6 is the first common multiple for both 2 and 3, and 12 is the next multiple, common multiple of both 2 and 3. So, what do you observe from the above number line? We observe that the multiples of 2 are 2, 4, 6, 8, 10, 12, 14 and so on. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24 and so on. And as you observe here, the common multiples are 6, 12, 18, 24 and 30. The next one will be 36 and so on. So, let us write the common multiples of 2 and 3, 6, 12, 18, 24, 30. Now, in these multiples, what is the smallest multiple or least common multiple? That is, as you can see here, it is 6. Thus, we can say that the LCM of 2 and 3 is 6. Now, LCM by prime factorization method. Find the LCM of 36 and 60 by prime factorization method. I have written the factors of 60 as 2 into 2 into 3 into 3, factors of 60 2 into 2 into 3 into 5. What are the common factors in both of these? The common factors for both are 2 into 2 into 3, and the same you can see here 2 into 2 into 3. Now, what is the LCM? LCM is found by the product of all the common prime factors of two numbers and extra prime factors of both. So, you can see here the common factors are 2 and 3, and in this slide you can observe here we have some extra factors, that is 3 and 5. So, that also we are going to multiply here to get the LCM. So, the LCM of 36 and 60 is equal to these 2 into 2 into 3 are common multiples, into 3 into 5, these are the extra multiples. So, which gives us 180 as the LCM. Now, if one of the two given numbers is a multiple of the other, then the greater number will be the LCM of the given numbers. Find the LCM by division method. Now, find the LCM of 24 and 90. Now, you can see here 24 and 90 both are divisible by 2. So, 2 12s are 24, 2 45s are 90. So, next 12 and 45, the common divisor is 3. So, if you divide these two by 3, we are going to get 3 4s are 12, 3 15s are 45. Now, here 4 and 15 we do not have any common multiples. So, we can stop here and find the LCM of 24 and 90 by finding the product of all these factors, that is 2 into 3 into 4 into 15, and the LCM will be equal to 360. Now, the relationship between LCM and HCF. Now, consider the numbers 18 and 27, and factors of 18 are 2 into 3 into 3. Next, factors of 27 are 3 into 3 into 3. Now, what are the common factors in these two cases? 3 and 3 are common factors. So, let us find the LCM and HCF. LCM of 18 and 27, as we all know, we have to multiply the common factors and the extra factors which are left out here. So, 3 into 3 into 3 into 2 gives us 54 as the LCM. Next, HCF of 18 and 27, 3 into 3, that is equal to 9. Now, LCM of 18 and 27 is 54, HCF of 18 and 27 is 9. Now, let us establish a relationship between these two, that is LCM into HCF. If you find out here, you can see LCM is 54 and HCF is 9. The product of these two gives us 486. The next one is the product of two numbers 18 into 27 also gives us 486. We notice that the product of LCM and HCF of two numbers is equal to product of the given numbers. Now, let us take one example and see. Find the LCM of 8 and 12 and then find their HCF using the relationship. Now, first let us find the LCM of 8 and 12. As you can see here, 8 and 12 both are divisible by 4. So, let us divide 8 and 12 by 4. 4 2s are 8, 4 3s are 12. Now, find the LCM of 8 and 12, that is 2 into 3 into 4, that is 2 3s are 6, 6 4s are 24. As we got the LCM, we will find the HCF by using the relationship. We know that the LCM into HCF is equal to product of the two numbers. So, as we want to find the HCF, we will write HCF. As we want to find the HCF, we will write here HCF is equal to product of the two numbers and take LCM to the right side. So, product of two numbers by LCM. So, next, so product of two numbers we already seen that 8 into 12 divided by the LCM of two numbers already we have found, that is 24, which gives us 4. So, now the HCF of 8 and 12 is 4. In this class we have learnt about finding the LCM and HCF of the numbers given. So, let us meet again in the next class for further classes. Thank you very much.